Multiprocessing.Pool. What's the difference between map_async and imap? I'm trying to learn how to use Python's multiprocessing package, but I don't understand the difference between map_async and imap. I noticed that both map_async and imap are executed asynchronously. So when should I use one over the other? And how should I retrieve the result returned by map_async? Should I use something like this?
There are two key differences between imap/imap_unordered and map/map_async. The way they consume the iterable you pass to them, the way they return the result back to you. Map consumes your iterable by converting the iterable to a list, assuming it isn't a list already, breaking it into chunks, and sending those chunks to the worker processes in the pool. Breaking the iterable into chunks performs better than passing each item in the iterable between processes one item at a time, particularly if the iterable is large. However, turning the iterable into a list in order to chunk it can have a very high memory cost, since the entire list will need to be kept in memory. Imap doesn't turn the iterable you give it into a list, nor does break it into chunks, by default. It will iterate over the iterable one element at a time, and send them each to a worker process. This means you don't take the memory hit of converting the whole iterable to a list, but it also means the performance is slower for large iterables, because of the lack of chunking. This can be mitigated by passing a chunk size argument larger than default of 1, however. The other major difference between imap/imap_unordered and map/map_async is that with imap/imap_unordered, you can start receiving results from workers as soon as they're ready, rather than having to wait for all of them to be finished. With map_async, an async result is returned right away, but you can't actually retrieve results from that object until all of them have been processed, at which point it returns the same list that map does. Map is actually implemented internally as map_async.get. There's no way to get partial results, you either have the entire result, or nothing. Imap and imap_unordered both return iterables right away. With imap, the results will be yielded from the iterable as soon as they're ready, while still preserving the ordering of the input iterable. With imap_unordered, results will be yielded as soon as they're ready, regardless of the order of the input iterable. So, say you have this. This will output. If you use p.imap_unordered instead of p.imap, you'll see. If you use p.map or p.map_async.get, you'll see. So, the primary reasons to use imap/imap_unordered over map_async are: your iterable is large enough that converting it to a list would cause you to run out of / use too much memory. You want to be able to start processing the results before all of them are completed.
The accepted answer states that for imap_unordered results will be yielded as soon as they're ready, where one might possibly infer that results will be returned in the order of completion. But I just want to make it clear that this is not true in general. The documentation states that the results are returned in arbitrary order. Consider the following program that uses a pool size of 4, an iterable size of 20 and a chunk size value of 5. The worker function sleeps a variable amount of time depending on its past argument, which also ensures that no one process in the pool grabs all the submitted tasks. Thus I expect each process in the pool to have 20, 4 equals 5 tasks to process. Prince. You can plainly see that these results are not being yielded in completion order. For example, I have been returned 1,621,512,519.7,743,165 followed by 1,621,512,515.268,784, which was returned by the worker function more than 4 seconds earlier than the previously returned result. However, if I change the chunk size value to 1, the printout becomes This is in completion order. However, I hesitate to state that imap_unordered will always return results as they become available if a chunk size value of 1 is specified, although that appears to be the case based on this experiment, since the documentation makes no such claim. Discussion. When a chunk size of 5 is specified, the 20 tasks are placed on a single input queue for the 4 processes in the pool to process in chunks of size 5. So a process that becomes idle will take off the queue the next chunk of 5 tasks and process each one of them in turn before becoming idle again. Thus the first process will be processing X arguments 0 through 4, the second process X arguments 5 through 9, etc. This is why you see the initial X values printed as 0, 5, 10 and 15. But while the result for X argument 0 completes before the result for X argument 9, it would appear that results get written out together as chunks and therefore the result for X argument 0 will not get returned until the results for the X arguments that were queued up in the same chunk, i.e. 1, 2, 3 and 4, are also available.
If you would like to